Good morning, everybody. This is Kevin Renaud with Peerless. Thanks for joining us this morning for another weekly session. This week, it's with OPW, the right fitting for the right application, and the evolution of fittings. We're going to go ahead and just get started. So here at Peerless, many of you know us as a distributor of a lot of process components and hose manufacturer. We've been doing it for quite a few years here in Buffalo. We have three segments to our company. Our ProCore segment is we work with a lot of OEM customers and package and skid builders. Certainly the process group, which most of our audience today would be in this group. And we have our high temp fabrication group where we work with high temp insulation, refractory product, and lab surfaces. So we have Dave Morrow joining us from OPW, Director of Product Development. We also have Bill Burns. And from the Peerless side, Dan Morgan, we have Greg Barrell, who's our business development guy for our process group, excuse me. And there's me, Kevin Renaud. So it was a few weeks ago that we learned a little bit about Dave Morrow, and among many things, he is a Bengals fan. So this week, Bill Burns is also joining us, and something little known about Bill is he once turned down an opportunity to audition as a drummer for a rock band, and that band did go on to have some marginal success. And so, Bill, having went on sales calls with you, I would say it's never too late to follow your dream, buddy. So
That's awesome.
I will move on from that disturbing image and get to a much better looking image of Dan Morgan. I'm going to turn it over to Dan. He is going to go through some housekeeping, and then we'll get it over to Dave Morrow for the presentation. Again, thanks for joining us, everybody.
Thanks, Kevin. I don't know how to follow that, but I just want to cover a few things here. Some people have been with us before here, so you kind of know the drill, but in case this is your first time joining us for a webinar, just want to mention how we sort of handle the question and answer. You will see in the control panel a section for questions. So as Dave is going through the presentation, if anything comes up that you'd like some further explanation on, or you have maybe an application specific question you'd like to ask, definitely feel free to submit a question through that panel. I will be keeping an eye on that the entire time, and then interjecting during the presentation to get an answer from either Dave or Bill. So yeah, please feel free to submit anything you'd like through there. And with that, I'll now turn it over to Dave.
All right, guys, good morning. So I did not know that about you, Bill, so that's good to know that you're an aspiring rock star. So let's get going, guys. We appreciate you being with us this morning. We've been working with Peerless for many, many years, many decades, actually. So it's always great to get together with the Peerless team. We appreciate you taking time out of your schedules to be with us virtually. Certainly interesting times today, so we appreciate you taking some time to be with us today. So let's get started. What we wanted to do is really tell a story. Let's see if I can get my slides to advance here.
You might need to click within the presentation, potentially.
There we go.
There you go.
So what we want to do is just kind of walk through the history and the evolution of couplings. Really from the beginning of couplings and how they started with threads and flanges and how we got today to where many people use dry disconnects, and there's lots of different specialty connections. So what we wanted to do is just kind of run through the history, how things have changed over time, help you understand the options that are available, and hopefully that'll help you understand what you could do on future projects to make your operations more efficient and safer. So let's start at the very beginning. So with threads, I mean, threads, super simple, super easy, very intuitive. Everybody knows what a thread is. It's the old righty-tighty, lefty-loosey. Used widely. These are mostly used for permanent connections, lower pressure applications. You do have torquing requirements. sealing requirements, pipe dope, Teflon tape, and things like that to get them to seal. So this really fits in where you would have a lower pressure permanent connection. But back in the day, people would literally thread up to make a connection to a tank truck or a rail car. So low pressure. So if people needed higher pressure, they would use a flange. So flanges really are for higher pressure permanent connections. So in North America, we use the ANSI standards. So it would be 150, 300, 600 PSI or class ratings, depending on the pressure requirements of your application. The issue with flanges, they take a lot of time to connect. So you could have 4 bolts, 6 bolts, 8 bolt connections that take a lot of time. There's torquing sequence. As you torque the bolts, you have to do it in sequence. There's gasketing requirements. So widely used, but mostly this would be for a higher pressure permanent connection. So what if you're going to have repeated connections? So repeated connections would be at the loading rack. So if you're loading a transport, loading a tote, or a tank or something that's going to be a repeated connection that you're going to have to do very often, doing a thread or doing a flange doesn't make a lot of sense. Takes too long, takes a lot of time. You got to follow all the sequences to get it done right. So unions were developed. And a union that you see here in the picture is basically a threaded connection that threads on. And when you get it threaded, there's a gasket or seal that's gonna seal it up. The disadvantage of this union, of this type of connection, is that it requires a tool. A lot of people refer to these as hammer unions, so requires the tools to get it tight. They hit it with a hammer, and when you hit it with a hammer to tighten it, it can damage the seal or gasket. So it could be something that requires a lot of maintenance and servicing over time. So there's some better alternatives that we'll look at later in the presentation. So the union is a high pressure repeatable connection. The next type of connection would be a cam and groove fitting. So KAMVALOK, this would be used for a lower pressure repeatable connection. OPW invented the KAMVALOK. So many years ago, I'm not sure the exact time, but it's getting close to 100 years ago, the KAMVALOK was invented by OPW. And our company started in the oil and gas business, mainly with petroleum and diesel and different types of fuels and oils. And what people wanted was, when they're loading transports, a quick, easy way to make the connection. So that's really where the KAMVALOK was born. Today, many people make KAMVALOKs. They're interchangeable. It's made to a mil spec. So KAMVALOKs are widely used throughout industry. There's many manufacturers that they're 100% are interchangeable. The disadvantage to a KAMVALOK or cam and groove connection, they're very limited. They're really designed for low pressure applications, so less than 250 PSI. It is a quick connect. So when we say quick connect, a quick connect doesn't have anything that's going to keep whatever's in the line from coming out. So when you uncouple it, whatever's in the line is coming out. The other potential issue with cam and groove is vibration in the lines could cause the arms to open. So the thing to take away from cam and grooves, these are really widely used throughout industry, because they are so available. Many manufacturers. You walk through a plant, you'll see many KAMVALOKs being used, and really a lot of applications where they really shouldn't be used. I mean, this is really designed and intended originally for lower pressure, lower hazard applications, and in liquids only. But we've seen these being used in hazardous service, where it's really not a great idea. We see them used in steam lines, airlines, and this should only be used for liquids only. So lots of people make KAMVALOKs. there are some differences. So just a couple of points that we do with our cam lock that make it a little bit different. It's very subtle, but it makes a big difference in the operation of the fitting. So we have what we call our twin cam, which you can see here on the arm. There's a small divot, and what that divot does is if you would have vibration in the line, the arm would partially open and catch in that divot. So that would prevent the arm from fully opening. So a cam lock without that twin cam feature would fully open, whatever's in the line would come out and you'd have a release. So the twin cam is a safety feature that if you would have vibration, it's going to keep that fitting from coming off. So all cam locks are not the same. There's another feature that we have with ours. That's again a subtle feature, but makes it much nicer to operate, and that's our spring ring. So the spring ring you can see here on the left, it's a spring-loaded ring, so they always stand upright. On the right, you see just a normal spring ring from another type of cam lock, and you can see that the rings could flip down and interfere with the closing of the arm. Doesn't seem like a big deal, but if you're in a chemical plant or refinery and you're trying to close things with chemical gloves on, it can be something that just makes the operation a lot more efficient. So we're all about safety, and everybody wants to be safe. So there is that risk of cam locks opening. So a lot of people take steps to try to prevent the arms from coming open during the loading process. So what you see on the left is a pretty primitive way to do it, but you see this throughout industry where people just put straps on. So just Velcro strap it to keep it from coming open. There are better ways to do it, and we have a locking arm version, and other manufacturers also have a locking arm version of a cam lock, like you see on the right, where it's a mechanical lock, and you can kind of see in the picture. So as the arm would close, it's a spring-loaded pin that locks it in the closed position. So that arm would not open until you bump the locking mechanism, and then the arm could open. So this also comes with the twin cam. So the twin cam gives you kind of the first level of safety. The locking arm gives you another level of safety. If you really wanted to be safe, you could strap it. Give you 3 levels of protection with cam and groove. So we talked a little bit about quick connects, and people use them, throughout industry. That's how trucks were loaded, how trucks were unloaded. They would walk out, they would thread up connections to get the loading done, or they would flange up to get the connection done. And that is still done in some parts of the world. Even in the US, you see it occasionally. People back in the day, as industry progressed, they started to be handling more hazardous products. It was beyond just petroleum and oils and things like that, where they don't want to get product on the ground. They want to keep it off the ground, keep it out of the atmosphere, protect their people, protect the environment. So they wanted something more. So this kind of led to the evolution of dry disconnects. So what started was people had just quick connects, and that's what you see on the left. Whatever's in the line with a quick connect is going to come out, and you're going to have that loss. So what people started to do was they would combine a quick connect with a valve. So they put a valve directly behind the quick connect. So when they would uncouple, they would close the valve and have less drippage when they disconnected. What OPW did was we looked at that and said, hey, let's combine a cam and groove connection with a valve. And the KAMVALOK was born, and that's what you see here. And this was really the first dry disconnect. This was about 80 years ago that the KAMVALOK was developed. And you can see here that the front of it is a cam lock in the front. It's just a cam and groove connection, and directly behind it is a valve. So the valve is behind it. You have a handle that operates the poppet. So it's a poppeted connection. So when you open and close the handle, it's going to move the poppet forward. And when it goes on the adapter, you see on the right, the poppet pushes the spring-loaded poppet on the adapter forward, and you have flow. So this is in 1 to 3 inch sizes. Originally, it started for just fuels and oils and things like that. Again, the petroleum roots, but it's evolved to where we do these in stainless. So 1 to 3 inch sizes, aluminum and stainless. Standard features on this would be the twin cam on the arms, locking arms. So the arms are auto locking. And then the handle, it locks in the open and the closed position. So that is the KAMVALOK. Kind of it's a flagship product for us now, but that was the first dry disconnect. And this short little snippet here kind of shows you how it works. So there you go. Great product. Again, aluminum and stainless. And one other note here, it's a safety coupling. So if you would open this coupling without it being on the adapter, it will not leak. There's a spring-loaded cylinder that would keep any product back from leaking. So it's very safe. The only way to get product out of this is to have it on a mating adapter. So the KAMVALOK was the first. And what people wanted, as industry evolved, there was more heavy chemical. And there's a couple of pictures of KAMVALOKs in use, KAMVALOKs on rail cars. So a lot of these, they live on rail cars, and it's how a lot of rail cars and tank trucks are loaded and unloaded is through KAMVALOKs. So as the industry evolved, people wanted more. So people started using more hazardous products, more corrosive products. And with dry disconnects, there's normally a concern with flow. They want better flow, and they want less drippage. So with the KAMVALOK, you will get some drippage. And as you get into the more of the heavy chemicals, drippage becomes more of an issue. So the DRYLOK was developed to address the flow and the drippage issues. And you can see in the pictures here, how we did that is with the flat poppets. So the flat poppets gives you very little place for product to collect and hide. So when you uncouple, you have very little drippage. And the other thing you see is kind of a bell-shaped adapter and body. So that gives us much better flow characteristics through the coupling. So the DRYLOK was born to give better flow and less drippage. And the other difference with this is it's more for heavy chemical. So we do both stainless steel, and we can also get into the Hastelloy. So with more aggressive, more corrosive fluids, the DRYLOK's a great solution. So this, again, will kind of show you how the DRYLOK works. All right, so there's the DRYLOK. So again, super safe. You can kind of see through that video, the handle is locked. It has safety interlocks to open and close. If it is not on a mating adapter, you cannot open it. So very safe. again, just like with the KAMVALOK, there's a lot of applications where these they live on rail cars, and what you see here is a butadiene. So a lot of butadiene cars that are out there, they are standard, where the cars are outfitted with the adapters, and then when they load them, they've got the arms with the DRYLOK couplers. So widely used. This product really has become kind of the loading rack dry disconnect. So it's very rugged, very durable, holds up really well for heavy chemical use at the load rack. So another type of dry disconnect is our Twist-Lok. There's many manufacturers of this product. It's based on a NATO standard, widely used throughout Europe. So lots of manufacturers of this product. Toto is probably the most well-recognized brand for this type of product. They're all interchangeable, just like with KAMVALOKs, fully interchangeable. So any of the manufacturers of a NATO style coupling can interchange, including our Twist-Lok. Where this fits in for us is in higher pressure applications, because most dry disconnects were limited at 150 psi. So the KAMVALOK, the DRYLOK, they top out at 150. There are some applications that need up to 360. The biggest ones that we see would be LP gas, so LPG, and an ammonia. So when you get into those with pressure railcar loading applications, this is a great solution. So it gets us that much higher pressure rating. The other nice thing is you can see in the pictures, there's no operating handle. So the actual opening and closing of the valve is done by the coupling of the device. So as you twist it, the twisting action opens and closes the valve. So if you're in a tight space, you're in a cabinet, this is used a lot in offshore applications where space is at a big time premium. That's where this fits in. So this video kind of shows you how this guy operates. So again, as it goes on to the adapter, you twist it, and as you twist it, the twisting action is driving the poppets to close, to open and close. So there you go. When it's so pretty slick. Okay. So we talked about several different types of dry disconnects. So the KAMVALOK, the DRYLOK, the Twist-Lok, all poppeted type dry disconnects. So they all have poppets, like you see in the top pictures here. Poppets on the coupler side, poppets on the adapter side. So to have the poppets, there's a lot of hardware and things that are in the line to support the poppet. So there's poppet guides, there's poppet springs, and things like that. So it's areas where things can collect, product can collect. It's going to create turbulence and really create pressure drop. And then depending on the type of dry disconnect that you're using, there's going to be different levels of drippage. Some poppeted type dry disconnects are better than others, but there generally is going to be some drippage at disconnect. There's another type of dry disconnect that is a non-poppeted type of product, and it's based around a ball valve. So what you see in the bottom is this ball valve, non-poppeted type of dry disconnect. So it basically, the principle is two ball valves that are nested together when it's connected. And when those balls are open, you have clean, uninterrupted flow through the unit, just like with a ball valve. So virtually zero pressure drop through the device. And when you close the balls are self-cleaning. So you get virtually no drippage at disconnect. So it's really kind of the best of the best when it comes to a dry disconnect product. It gives you the best in flow, and it gives you the best in drippage, or the least amount of drippage. And where that flow can be important is in a situation if you're loading a tank or unloading a tank or a process. You know, that difference in flow can make a huge difference in some applications. You can see here what we're showing is a 2-inch non-poppetted dry disconnect versus a 3-inch poppetted. That 3-inch poppetted, even though it's a larger size, still would be way slower, you know, 65% slower than a 2-inch non-poppetted. If you compare a 2-inch non-poppetted to a 2-inch poppetted, it's almost 200% slower than it would be with a non-poppetted. So in some applications, that flow pressure drop can be super critical to that application. So if you think about how many tanks you load per day, per week, per month, per year, and you start doing the math on that, what it can mean to the operation, it could be really, really significant. So that's a lot of the applications that we look at for Epsilon, or this non-poppetted version. Flow is very important, and also product loss, because again, it virtually has zero product loss at disconnect. So this is what this product looks like. Again, it's a double ball valve on both sides. One has a concave ball, the other has a convex ball. So when you put them together, they nest. And then once it's together and you open the balls, you'll have that clear flow through the unit with uninterrupted flow. So virtually no pressure drop, virtually no drippage at disconnect. And this kind of shows you what that looks like. All right, so that's a non-poppetted dry disconnect. We call that our Epsilon. Really cool product. We've really grown. A lot of our customers, you know, they really are looking at flow. And the other thing that's really important to people is product loss. So people are really looking at how much product do I lose per connection? And if you think about a plant with hundreds and thousands of connections, and if you lose a little bit with every connection, it adds up over time. So we work a lot with companies that have high value fluids. We're losing a drop, it's losing money. So what you see here is some Epsilons on tank trucks. So we do a lot of do some on transports. This product's more common in plant, in process, where they're making a lot of repeated connections throughout the process. So a lot of farm applications, a lot of high value fluid applications. That's where this product fits. So there's a lot of different types of dry disconnects. So we just kind of ran through the most common types that we see in the market here in North America. And a lot of people, they get confused with, okay, where does this fit? Where do I use this product versus this product versus this product? And we try to do studies on where do people use a KAMVALOK type product? Where do people use Epsilon type products? And what we found is that it's hard to put things into buckets, because the things that are important to one plant or one operation could be different than in another plant or operation. So one plant flow could be super critical. So they would look more at Epsilon or a DRYLOK where they're going to get better flow. Or another plant, flow really doesn't mean anything. So they would, to them, the KAMVALOK could be fine. So we put together a little cheat sheet to try to help people understand where these fit. And the things that we look at: flow, drippage, the price, because the price does vary, pressure, and then ergonomics. But in general, the way it works is the flow performance improves. You know, it's kind of a good, better, best scenario. As the drippage performance or dripping less, you know, again, good, better, best. As you kind of step up in class, the price point steps up as well. So you can see here. And then outside of that, the other points would be pressure. So sometimes pressure is going to kind of point you to what type of connection do you need. So a good little cheat sheet on where everything kind of fits. So connections are everywhere. You know, we deal with all types of fluids, and it's really important to think about what type of fluid is it, what are the hazards of that fluid, what is the value of that fluid, the pressures that you could see, the temperatures of both the product and the environment. You know, the temperature in northern climates, that can play a big role in what coupling are you going to use and what seals are you going to use within that coupling. And then the flow. You know, how important is flow or pressure drop to that application? So we see everything. You know, when we move fluids, it's everything from Jack Daniels. So we're proud to say that every drop of Jack Daniels goes through a KAMVALOK and an OPW loading arm. You know, from lube oils to paints and resins to ethyl methyl def and everything in between. So, and it's really important to think about that fluid and that application and what's important to it, and it's going to vary. And the nice thing is there is, as we just kind of reviewed, there's a lot of different types of units that you can use depending on what's important to that application and that fluid. In general, what we want to do is keep product in the pipe. I mean, a lot of systems early on, and you still see a lot of plants today that are open. And when we say open, it's open connections. So it's CAMLOKs. And what we're trying to do is move people toward closed systems, where it's not an open system, it's a closed system. Even if you clean out a line, you blow a line down, you still have residual product that's left in that pipe. And if it's an open connection, you're going to have emissions. So we want to keep the product in the pipe. And the other thing to think about is where people meet pipe. If you think about a plant or an operation, the area or one of the areas where you have the highest risk in a plant is that place where your operator is going to have to make a connection, where people meet pipe. Because you think about back in the process where you have permanent connections, they're pretty safe. They're there, they're in place for many years. It's not a lot of risk. Where there's risk is where you're making those repeated connections where a person has to make it. So it's important to think about that person and the people where they meet the pipe. So in general, the higher the risk, the higher the hazard, the higher the value of that fluid, the more scrutiny we're going to want to put on the connections. So just wanted to have a few more slides here. Just wanted to touch on some specialty connections, and really the specialty, it comes in the form of extreme temperatures and extreme pressures. So both low and high temperature and pressure. There's fittings that are designed to handle those types of situations. So the first is for extreme temperatures. So both high temperature, and the problem with high temperatures is seals that are used in most couplings would melt and not handle high temperatures. And at low temperatures, those seals would get very hard and not seal. So if it's a cryogenic type product, or it's in an environment that's very cold, where the seals are not gonna, they're just gonna get rigid and they wouldn't seal. So there's a metal to metal type seal that you see here. So it's the principle is it looks like a union, a threaded union. So as you thread this on, you're going to drive this metal wedge into the adapter, and the primary seal is a metal to metal wedge seal. So it's impervious to temperature, impervious to pressure. So it's good for really high pressures, really high temperature, and really low temperature. So we have a little snippet here to show you what that looks like. Okay. So that's a metal to metal wedge seal. That would be our 3TL is what we call that. So the next thing I wanted you to think about is, we talked about cam locks and cam and groove connections that are used widely. So they're everywhere throughout industry. And the one thing when you're making a connection, again, that where people meet pipe thing, is when you make that disconnection, especially with a quick connect like a cam and groove, is there pressure in the line, and what happens if there is? And wanted to show you a scenario of what that might look like. So what you're going to see here is a little video, just a quick little snippet. This is a line that has 60 psi on it with a cam and groove cap. So this would kind of simulate if you're in a plant with a cap and there would be pressure on it. Obviously, normally you wouldn't have a pressure gauge that shows you, hey, there's pressure here, don't open me. But what happens if you would remove that cap with pressure? So yeah, so that's not great. And if there would be fluid in the line, obviously to have a release, you could have somebody potentially injured. So we developed a product to address that. So people came to us that had this very issue and said, hey, can you fix this? So we developed a product, we call it our locking quick coupler, or LQC. So what you'll see here in this video is the exact same scenario, 60 psi in the line. And if you try to remove it under pressure, you can see what happens. So you can see with the pressure, it catches. So you can kind of see it here in the video picture. There's a little divot that if there's pressure in the line, it's going to catch in that divot, and you will not be able to get it off. And you can hear it catch in the video where it catches in that groove. With no pressure, it just bypasses the divot and it comes right off. So very safe. Very safe product. So super cool. We call that our LQC, and really was designed as a safer alternative to cam and groove. And this again goes to the point that cam and grooves are used in a lot of places, and probably places where they shouldn't be used, in those more hazardous applications where you're using cam and grooves. This could be a really good alternative. And for those older people in the crowd, yours truly, I'm included in that crowd for sure, but the radiator cap, it's basically a radiator cap that if there's pressure, it's not coming off. So super safe. And one final thought on couplings and connections. So if we're going to make a connection to something, and normally in our world, we're talking about connecting to a transport, something that's going to move. This is a scene that you've probably seen something similar. Every time you get gas, you look at the top of that hose, you're going to see a safety breakaway. That's become standard in the industry to prevent this. So if someone is fueling and connected, and they decide to jump in the car and drive off, it's going to pop off and be safe. In our world, in the chemical plants, refineries, and places like that, there's not a lot of this going on. They're not widely used today, but it's something that is becoming more common. Unfortunately, you do see these types of situations like you see here. You're connected to the rail car in this case, and somebody decides to connect to those cars and start pulling, and it'll rip the platform and the piping and the people, if there's people up there. It could be a really bad situation. So one thing that's becoming much more common in the chemical petrochem world are safety breakaways that are designed for chemicals, petroleums, LP gas that would be incorporated into the loading lines. And you can see here, this is an LP gas loading arm, and at the top of the hose, just like you'd see in a retail fueling situation at the gas station, at the top of the hose, there's a breakaway. So if that car would be pulled away, it's spring loaded, pop it in on both sides, would pop off and would be safe. So it protects the equipment, protects the environment, the people. Still not widely used yet, but it's one of those things that we think, over the next 5 to 10 years, it'll be much more common to see this in these types of applications. So we'll kind of wrap up with just a few final thoughts. So went through a lot of different connections. So the reality is a bad connection is bad. So it can be bad for the environment, bad for your people, and bad for your bottom line. So wanted to share some data just around this. So the EPA, they publish the LDAR report, which is a leak detection and repair report. That you can download this on Google, but it talks all about how much emissions and how much product loss there is in a plant, and it's big numbers. So that what their data says is that there's over 70,000 tons per year of VOCs that are emitted from leaks, from leaks within a plant. So where do those leaks come from? Where do we see those VOC? Again, the LDAR data, what it says is that a big percentage of that leakage, of that loss that you see, is coming from connections and coming from open-ended lines. And you see here the more recent data on open-ended lines, it's more like 10%. So you take 5 to 10% of that plus the 31% from connections, it's approaching 50%. So a lot of the emissions in a plant are coming from the connections within a plant. So there's lots of opportunities to reduce emissions and keep things, keeping your people safe, keeping the environment safe. Connections play a big part of that. And then just some dollars around that. If you lose vapor or you lose product, that loss eventually is going to mean loss in revenue. So again, this is their data, the EPA LDAR data. Almost $750,000 per year per plant is what they estimate that the loss of revenue is through product loss. So, and when we talk about connections, it's target-rich environment. There's lots of connections. We said earlier, connections are everywhere. These numbers are the average number of connections in a typical refinery or plant. So over 12,000 connections and approaching 600 open-ended lines. So an open-ended line, again, would be what you see here. So an open-ended line is a cam and groove type line that's open to atmosphere. So these are the opportunities to possibly reduce emissions, saving money and keeping your people safe. So lots of opportunities to improve. So if you wanna learn more about connections, talk more about connections, Peerless is available. Again, we've worked with Peerless for many years. Great people. They're real pros at what they do. Bill Burns he's right there in Buffalo as well to support Peerless. So if you have any questions about connections, reach out to Peerless, and we'd love to help you.
Thanks, Dave. Yeah, that exploding plug video was a little frightening, but if you look closely enough, you catch a little glimpse of beauty in that video in the form of a station wagon with some, complete with wood paneling. I think it actually might have been Bill's car that he used to tote his drum kit around in. Is that right?
Close.
All right. So we actually don't have any questions in right now, but yeah, we will be hanging out for another couple of minutes. So if you guys do have anything that comes to mind here in the next few minutes, please do submit a question here. We'll make sure that we get an answer for you. Or of course, you're obviously free to follow up with us after the webinar. I'll turn this over to Kevin real quick, but there's one more thing I just wanted to mention. You will see a survey pop up once the webinar ends, and we'd appreciate it if you guys could just give us a little bit of feedback on how your experience was today. So thanks.
Thanks, Dave. Thanks, Bill. Hey, I do have one question. Actually, a situation came up this morning where we actually sold an 8-inch hose to one of our customers, and Marty had called me this morning about a problem, because although Marty was very diligent in making sure that we knew the type of fittings, type of cam locks we needed, this was an 8-inch hose, and I believe at some point, Dave and Bill, mil spec doesn't apply to cam locks. Is that correct?
That I'd have to check on that, because I'm not sure. I mean, I know in the smaller sizes that we, our normal size range, up to 4-inch, everything we do is to the mil spec. When you get up into those larger sizes, I don't know if there's some variation off of that. So I'd have to do a little bit of research on that to verify.
Okay, yeah. I believe from what Marty mentioned, it was over 6 inches. They don't uphold.
Yeah,
that
could be.
Okay, and we do have Marty was, again, he questioned what type of fitting we were connecting to, and they got the hose and they don't interconnect. So I believe over a certain size, it is important that we know that what type of fitting it is. So
yeah, that's a great point.
Yeah, and an 8-inch is kind of a little bit of a unicorn in a cam lock, just because it's really hard to kind of get a cam and groove to seal well when you have that large of a fitting, and not, because to go back to the mil spec, and they're probably right. Once you get to those kind of oddball sizes, maybe there's not a lot of compliance there, or data, but not because there's so many different manufacturers now. I wouldn't say that every cam lock should be made to a mil spec. There might be some, imports out there that are not made exactly to that mil spec, but they should be. So you'll find some variance.
Got it. All right. Well, thanks again, and again for our attendees, thank you very much for joining us today. We thank OPW again for all their support and showing up here again and helping us navigate these different types of fittings. Next week, we will be back on our normal Wednesday routine, June 24th. We already had our partners at Hosemaster in once to talk about when to use metal hose versus expansion joints, and it was very well received. So what we're going to be discussing next week is really focusing on expansion joints and why they fail, and some of the design criteria moving into it, and the do's and don'ts to make sure we do everything we can to avoid failures in the field. So again, if any lingering questions come in, we'll make sure we get back to you. And again, thanks OPW, and thanks for attending, everybody.
Thanks, everybody.
All right, bye now.
Take care.